Hello everyone, welcome to this video. So today we are going to solve this problem from the Brazilian mathematical competition. It's a Brazilian Olympiad that was conducted back in 1997, but the problem is a very interesting one. So we have to solve this set of simultaneous linear equations, where the second one is linear and the first one is of the kind exponential. So we can together call it, let's say, linear exponential equation set. Now, this might look a bit difficult because of the first equation, but the second substitution really makes it easy for us. And the conditions given are a greater than 0 and a not equals to 1, which are also very essential actually, as we will find out. Okay, so start with the first equation, x to the power y equals to y to the power x, and substitute in the value of y into this equation. Well, that is what we have to do, right? Because this equation was given for a reason. That is why we can reduce this two variable equation into a single variable equation. So when you do that, what you get is this x to the power ax equals to ax whole to the power x. Okay. Now we can write x to the power ax equals to, now this can be separated into two parts, namely a to the power x into x to the power x. And the left hand side, we can also write this as x to the power a whole to the power x and bring everything on the left hand side by dividing it. You can get a to the power x into x to the power x. Since we are doing operations with x and x to the power x is already present here, we can safely assume that x is not going to be 0, since it's also at the base and also at the numerators. So it's not going to be 0. Otherwise, the problem would be undefined, right? And this could be 1. Now, as you can see, all the terms have the same exponent x here, which means what we can do is we can write them together like this: x to the power a divided by ax whole to the power x equals to 1. Now, since x to the power a divided by x, what we can do is we can simplify it further. X to the power a minus 1, and 1 upon a can be written as a inverse, that is a to the power minus 1. And this is true because a is not equals to 0. And we must write it here as well. That is why we can do this, since a is greater than 0 and a is also not equals to 1, right? Okay. So from this equation, since x is not equals to 0, the term inside must be 1, right? Otherwise, we could not have a solution. So let's set x to the power a minus 1 into a inverse equals to 1. Because since this is 1 and this to the power x would always give you a 1. Otherwise, if x was 0 and this was anything but 0, it would have also given a 1, but x is not 0. Okay, solving this, you get x to the power a minus 1. Transfer this 1 upon a to the other side, you will get a. And then this basically is a variant of the nth roots of unity. So if we are looking for only real solutions, the real solution is simply a to the power 1 upon a minus 1. There is another solution where you can set this to minus 1, but in that case, what you basically have to hope for is that the value of x comes out as an even integer. That is, x to the power a minus 1 equals to minus a. And this thing, first of all, a should be something that makes this, that makes this cube, the root of a minus 1, which we are going to transfer it like this, which makes this real. So this has to be real, first of all. And secondly, the value of x must be an even integer. So those are a lot of requirements, and we cannot say that based on the just the value of a without given a numeral value, right? So that is why I have discarded this solution for now. So this is the only real solution we have for this equation. And if you're looking for imaginary solutions, you can produce them like this. You can simply write x divided by a to the power 1 by a minus a to the power 1 upon a minus 1, which is like a minus 1th root of a to the power a minus 1 equals to 1. And now this simply turns into a minus 1 roots of unity. This is similar to the equation x to the power n equals to 1. And when you solve x to the power n equals to 1, what you get is x equals to e to the power 2 pi ki by n, where k has n values starting from 0 all the way up to n minus 1. And putting each of those values will give you the n roots of this equation, which are called the nth roots of unity. In place of x, just substitute x upon a to the power 1 by a minus 1 and then multiply it on this side. You will get the required value of x for this equation. But that is for complex solutions. For real solutions, we only have one solution. Okay. Okay, so that completes the questions, but there could be doubts. Please let me know in the comment section if there are any doubts you have or any specific parts that you would like to clear out. So this was the problem from the Brazilian Mathematical Olympiad. Please subscribe the channel and also like the video if you like my solution. Thank you.